You are welcome to the educational video channel Maths for Maths. We hope to discuss 5 more short questions in part A of paper 1 of model paper for this video. The question number 11 is a triangular face of a square-based solid pyramid is shown in the figure. Find the surface area of the pyramid. Now this is the question number 11. First 10 questions we have already discussed in 2 videos earlier. So here a pyramid, a square-based pyramid. If it is a square-based pyramid, there must be 5 surface parts in that pyramid. One is square shaped, that's the base, and the other 4 surface parts are triangular shaped. So the measurements of the triangular face is given in the diagram. There the base is 8 and the height is 10 centimeters. So to find the surface area, first we can find the area of a triangular face. That is, area of a triangle is half into base into height. So here area of a triangular face is equal to half into 8 into 10, that is in square centimeters. When you simplify it, we get 40 square centimeters. So there are 4 this size triangles. To find the areas of all triangles, we have to multiply this one by 4 and add the area of the base, that is a square shaped one. Area of that one is 8 times 8. So 4 times 40 is the area of 4 triangles. 8 by 8 is the area of the base. So then when you simplify this one, we get 160 plus 64, that is 224 square centimeters. So that is very easy. Only thing is, first we have to find the area of a triangular face and 4 faces, and the base we have to add. Then we get 224 square centimeters. Now we will see the question number 12. Question number 12 is sum of 9 consecutive whole numbers is 180. Find the smallest number of this sequence. Here this question is based on arithmetic progressions, but if you use the formulas of arithmetic progressions, we will take more time and more space to get the answer. But if you pay your attention to some special features of arithmetic progressions, within 2 steps we can find the answer of this one. These consecutive whole numbers, 9 whole numbers. 9 is an odd number. If the number of terms of arithmetic progression is an odd number, there must be a middle term. Here the middle term is the 5th one. Is middle term and 2 equal parts in the other 2 sides. A smaller part 4 terms, larger part 4 terms, and middle term. So there is the that is how the 9 terms will be formed. The special shortcut is, if you know the middle term of the set of terms in which the odd numbers are included, odd number of terms are included, then to find the sum of the progression, we can multiply the number of terms by the middle term. Now here 180 is 9 times of the middle term. That is shortcut. So easily we can find the middle term. To find the middle term, we can divide this 180 by 9. Then you get 20. So 20 must be the middle term of this arithmetic progression. So there are 4 terms less than 20 and 4 terms greater than 20. So these are consecutive whole numbers. Therefore, we can go backward from 20 4 terms to find the smallest term. Then 20, 19, 18, 17, 16. That should be the smallest number. And if you want to find the largest number, we can go beyond 20, upward 20, 20, 21, 22, 23, 24 is the largest number. So the solution must be like this. Middle term of the sequence, to find the middle term, we divide this 180 by 9, that is 20. To find the smallest term, we can subtract 4 from 20, it is 16. So here we didn't use the standard formulas. We used to do some calculations in arithmetic progression, but we used one special feature of arithmetic progressions. You can try out taking another example also. So we will see that feature is correct for arithmetic progression. That is, if the number of terms of the progression is an odd number, to find the sum of all those terms, we can multiply the middle term by the number of terms. So that is the shortcut we use to find the answer here. Okay, now we will go to question number 13. That is about isosceles triangle. The magnitude of the angle at the vertex of an isosceles triangle is 72. Find the magnitude of a base angle. Now vertex angle is 72. The other two angles of the isosceles triangles must be equal. Therefore, to find magnitude of one base angle, those are known as base angles. So 2 base angles and 1 vertex angle. 2 base angles are equal. So we can subtract this 72 from 180 to find the sum of 2 base angles and divide it by 2 to find the magnitude of one angle. So it is like this. 72 minus 180 minus 72 divided by 2, that is 54. Therefore, the magnitude of a base angle must be 54. We will go to question number 14. There, find the gradient and intercept of y-axis of the straight line represented by the equation 2y equals 3x minus 6. Here, the equation of the straight line is given as 2y equals 3x minus 6. The standard form of the equation of a straight line is y equals mx plus c. So we can make this given equation, we can convert this one into the standard form, dividing all terms of the equation by 2. Then 2y divided by 2 is y, 3x divided by 2 is 3 upon 2x, minus 6 divided by 2 is 3. So this is in the form of y equals mx plus c. Now, if the equation is in the form of y equals mx plus c, m shows the gradient and this C minus the CE represent the intercept on y-axis. So here gradient must be 3 upon 2 and the intercept on y-axis must be minus 3. Gradient is 3 upon 2, intercept must be minus 3. So here we converted the given equation into standard form, and from the standard form we identified the gradient and the intercept. This is one way of finding gradient and the intercept, and there are some other methods also. In future with some examples we hope to discuss those methods. Now we will go to question number 15. Question number 15 is about midpoint theorem, that is x and y are the midpoints of the sides AB and AC respectively of the triangle ABC. If AB equals 6 centimeters, BC equals 7 centimeters and AC equals 8 centimeters, find the perimeter of quadrilateral BCYX. BCYX. So we have to find the perimeter of a quadrilateral. The perimeter of the quadrilateral is equal to BC plus CY plus XY plus XB, and these sides we can write in terms of the sides of the triangle like this. BC is already a side of the triangle and CY is half of AC and XY is half of BC according to the midpoint theorem. Midpoint theorem says if midpoints of two sides of a triangle is joined, that line is half of the third line in length, and that line is parallel to third side. So XY is half of BC, then XB is half of AB. So we can write that expression in terms of the sides of the triangle as BC plus half AC plus half BC plus half AB. We know AC equals 8. So here half of 8, BC is half of 7 here, and half AB is half of 6. So it is BC is 7, half of AC is 4, half of BC is 3.5, half of AB is 3. So when you add these values we get 17.5. so it should be the perimeter of the quadrilateral. So we used the knowledge of midpoint theorem to get the answer and the lengths of the quadrilateral, sides of the quadrilateral. So this is question number 15. So we have discussed from question number 11 to 15 here, and another video we will take to discuss questions from 16 to 20.